Hi, once again, you're welcome to this edition. I'm Tulade Ademisoye, a machine learning engineer. And in this edition, I'm going to be talking about the Falcon, uh, the Falcon large language model. In my last video, we're going to talk about how to deploy your first AI chatbot using Hugging Face transformers, blenderbot from Facebook AI, as well as Flask for the backend service. So in this exciting video, I'm going to be walking you through how you can take your first step with the Falcon large language model. All right. Before I start, I'm just going to walk you through. So first of all, let's just take a look at what exactly is a Falcon model. So basically, we have the Falcon 40B. That's a 40 billion instruct model, and as you can see, trained on 40 billion parameters. It has about 1 trillion tokens, as you can see. And so it's a very exciting model. And if you check out the what do you call the leaderboard, it's currently top in the chart, right? So the Falcon model is currently doing very well in top in the chart. So I recommend you try this model out. You try to use it for your next project, which is very interesting. All right, as you can see here. All right. So, but the challenge we have right now is the fact that the Falcon 40B model, it's very large, and the constraint we have for our Google Colab for the free tier is that we have about I think about is it 12 gig or so. Let's check it out. We have about 15 gig of RAM and of GPU RAM, so we need to see how we can maximize that resource. So let's just start with something. So if you look at this, I'm currently using the Falcon 7B, which is much lower. It's much lower than the 40B, but still it's still the same family of the Falcon model. And that's because we have a target. The target is I want to ensure that I'm able to utilize my RAM. I'm currently using GPU, so I recommend that you use GPU. Initially, when I started using the Falcon model, so basically using CPU is limited. You need to change your runtime to GPU on the Google Colab to make this work for you smoothly. As you can see here, all right. So this is the end result. Basically, you can see that I'm able to optimize my RAM, my system RAM, my GPU RAM, and my disk space. So which is very cool. So let's just take a step and then walk through. So the model I'm going to be using, like I said initially, I'm going to be using the Falcon 7B struct model. Take a look at this. This is a lifesaver here for many of you data and machine learning engineers, enthusiasts who would like to carry this out yourselves at home. Just take a look at this. So we're going to be making use of this model, the 7B instruct. I think I've dropped the link. The link should be somewhere on the Colab notebook. Uh, okay, cool. Right, cool. Let's just proceed. All right. So now one of the first and the critical things to do is to install our dependencies, right? And if you can see here, I've made two approaches to installing our requirement and dependencies. Either way they work, right? Either you can either use the first one or you can use the second one. Both of them are going to work very well for you. All right. So as you can see, I'm trying to install my bits and bytes, my transformers. Although yeah, I commented it out here because I installed my transformers here. I initially carried out this first step when I ran into some errors due to the fact that due to the fact that I had limited compute space before I switched to GPU. So I had to use the second approach. But for you can either carry this either of the two methods, and they're gonna work very well for you. All right. So once you're through installing these dependencies, and the next thing you want to do is you want to set up your bit and byte config, right? And this is very essential because the goal is to save memory. We want to save memory. Let's just take a look at this documentation that I used, which was able to guide me. So if you check out a link, you see there's a process called, let's just take a look at it. Yeah, from the top, so you can see. It's basically a process that helps us to save compute space. Um, it's basically called quantization, as you can see, and there are different approaches to it. Okay. All right, so we want to be able to set up our variables here, defining our variables here, and passing our loading bit 4. 4 bit is equals to true, as well as the other requirement that is needed for this project. All right. Okay, so I'm going to proceed to the next thing. All right, so now the first thing, if you this Colab notebook has 2 projects in it. And the first one is where I try to experiment directly with the Falcon 7B instruct model, right? I want to see how this model works, and I want to see how I can be able to query the model directly from my Google Colab, to try to draw out some inferences. All right, so cool. So let's just proceed. Let's proceed. Okay, so one of the critical things here, I'm going to import my transformers, my auto tokenizer, and if you watched my last video, I think I tried to explain a bit about transformers and auto tokenizer. You can check it out on YouTube or check out my Git repo. All right, and the next thing again is we want to import Torch, and from here. All right, so basically this is a model name, so you can check out this guy out. So basically it's done it did a it helped a lot. His work helped a lot. All right, so we're using this model name, and this model basically is the Falcon 7B instruct, the Falcon 7B instruct. All right, so we're going to proceed now. The next thing is after we've been able to define our variable name for our model. The next thing is we're going to want to set up our tokenizer, right? And not forget that the tokenizer is a class that enables us to download the what do you call it, the tokenizer for our model, for the model name, which in this case is the 7B, the Falcon 7B, right? So the next thing again is we want to define our model. That's a model, we want to be able to download our model class from here. And here we have the model name, which we were able to define here already. Device map is equal to auto. Initially, I tried experimenting with other approaches, but the auto really worked well for me. So I recommend you also do that as well. Then the quantization config, which we were able to define somewhere. Yeah, we're able to define somewhere here. Let's just take it up. All right. So we define it here as well. Then the trust remote code is equals to true. All right, cool. So you run this code. Okay, so it's telling me that my runtime is disconnected. I just basically have to reconnect. And that's because Google is trying to manage their own GPU resource. All right, so let's proceed. Cool. All right, so now the next thing is we want to define our pipelines, right? We want to see, basically, we're working on a text generation. Let's take a look at, all right, so it's a text generation, model. Okay, let's see. All right. So basically, yeah, text generation inference. So basically, it falls under text generation. We can also explore other methods as well. But basically, we're using text generation, the model, the tokenizer, trust remote code, the device map. Like I said previously, is auto. The max length is 200. So yeah, 200 is okay because we don't want to make it too lengthy. Use cache, do some, and so on and so forth for that. Okay, then we run this once we're through. All right. So the next thing for us is we want to be able to define our sequence variable. Now, this sequence variable is where it's like where you get to ask the model questions, right? You get to ask a set of questions, like for example, what is your name? What is my name? In the form of if it's a question and answer approach, so there are different approaches to it. So this is where we define this sequence here. All right. So the next thing is, so basically I can pretty much run this here, but I won't run this here because I don't want to run this again now. But now, so you can see that I made two approaches to this. All right. So I can either use a for loop here, or basically I can just what I can just do is after defining my sequence, I can pretty much initiate my sequence. I can pretty much call my sequence variable here as well. All right. So which pretty much okay. All right, so cool. So now one of the first things that we have here is we says create a list of 4 important things a car driver should take note of. So you can decide to change it. You can decide to say create a list of 4 important things. Probably a pilot, you know, let's say pilots should take note of. So I'm gonna run this here. So we're just gonna give it a second, a minute. All right. So I'm gonna check out my sequence from here. So let's run this to see. So you can see it's been able to do that. All right, aircraft altitude, airspeed, you know, meteorological information, including weather and air pressure, as you can see, and so on and so forth. All right. So this is the next stage. You can basically list out 5 early signs of pregnancy in women, and you can see, this. Okay. All right. Okay. Now the next thing we want to look at here is okay. Let's just take a look at the next one. The next prompt we have here is list 6 ways a manufacturing list 6 ways of manufacturing a car for me, like a 5 year, like a 5 year. So we're basically trying to test out the model. We're trying to see how well it's able to have a human-like conversation, right? In comparing with OpenAI ChatGPT. So when we did this, when I ran this, as you can see, I have to list 6 ways. And in the first question, the first response is using blocks of raw materials like plastic, metal, glass, assembling these materials into car components, and pretty much it was cool, it was okay, it was fair enough. The next thing is the okay. So basically, I can either use after defining my sequence variable here, I can decide to use a for loop here, or I can just pretty much call my sequence again to give me a response. So either I use this, okay, or I use this, depending on how I want my output to look like, but they're pretty much similar in the same response. All right. So that is pretty much me interacting with the Falcon 7B model directly. So this time around, let's try and play with it using Langchain. I'm sure you must have heard about Langchain before. I'm not going to introduce Langchain in this video, but I'm just going to give you a walkthrough. All right, now you might need to run this now due to the fact that I have 2 projects in this, 2 closely related project in this notebook. So sometime if I run the first one, if I run the first project first, I'm going to need to run this code again because sometimes it might give me an error if I'm trying to install my LangChain. Okay, but for now we're good. So pip install LangChain on our Colab. Okay, cool. The next thing is that we've done this before. Basically, we're going to import the required dependencies. We've been able to define our model name. Yeah. The next thing, like the same thing as well, the classes for the tokenizers and the model. Don't forget that the tokenizers helps to break the word into bits, and the model needs to understand the the model gets an information or a data in a way it can understand it, right? In bits, in several bits. Okay. And also the user also gets information in a way that we can understand. So it's a two-way approach. So here again as well, I think I did this method previously when I interacted with the Falcon 7B model directly. So I think I can pretty much just jump this section. All right. So the next thing is that we want to create a pipeline for our Falcon model using the same Langchain. So from Langchain, we're going to import the Hugging Face pipeline. All right, the next thing we're going to do is we're going to want to define our, what do you call it, the language model variable. And this is where we're going to call the pipeline into works and to define the temperature. This temperature is, we're trying to say, okay, the model should be able to, it just defines how the model, thinks, and it shouldn't, and the kind of responses, how, shouldn't hallucinate. I think that's the word for it. All right. So the next thing is that we want to import a prompt template, which is very critical. I think I'm going to show you why this prompt template, and this Langchain is very critical to our project. So let's look at template one. So in this template, I'm telling my chatbot that my chatbot, you are an intelligent chatbot that can function as a brand copywriter, customer service manager, and have the ability to insert opinion on current affairs, media trends, and general commentary. So pretty much this. All right, so now this is where I get to define the prompt. Now this prompt is very critical in the sense that because for this prompt template method, we are going to be able to marry the template and the input variables in this particular method. We're going to then now run the Langchain. Don't forget that we're able to import the Langchain from previously. The LLM Langchain, we imported it before, so we're going to call it here. From here, we're going to, by calling this, we're going to, we'll be able to define our prompt. So the prompt is equal to prompt, and the LLM is equals to the LLM as we're able to define somewhere, I think, where is it? Yeah, somewhere here. Maybe also factorize this pipeline. Cool. All right, so now what we're going to see is we're going to ask a question. How do I pay for a service? Right man approach for this. You can decide to change. Let's do something new. Let's say query is equals to okay. Let's see what kind of question should we ask. Let's say how do I how do I pump water into a tank from a borehole? Oh, yeah, cool. So there's a question. All right. The next thing is we want to be able to print, okay, LLM chain, yeah, dot run. Then we're going to pass this query again. Okay, so I'm going to run this. Oh, there's something else again. Yeah, so if this gives us an error, I'm going to explain it why it might not give us the output that we need because I need to run, just a sec, I need to run this again. I'm going to run this again. Yeah, cool. I'm going to run this template again. Yeah, okay. Then I'm going to run this again. So let's just wait and see. That's because I use a different template below in the notebook below, somewhere below. So that's why I'm having to run that again. All right. So we're just going to wait a second, and I'm just going to load. So now we can see how we can interact with our language model, and we can see how. Okay, cool. So this is a bit more cool. All right. So you said I need to drill water, a hole rather, in the ground, connect a pump to the water source, and then pump. So this is pretty much interesting, right? It's interesting. Cool, cool, cool. I think I like this. I like that's not bad. So yeah, I'm asking you where can I request a refund of my money? So this is pretty much the same process with this. So what if we have a different or alternative template method? All right, that's very critical. So you can see that if you look at this dictionary, the key and the pair is quite different. So from here, we're going to have a different prompt such that we're going to have a question. Well, it's going to return the question, then the question and the answer. So let's take a look at this. So for example, for example, when we click on or when we input how to prepare a Nigerian eba. Nigerian eba is a Nigerian delicacy, it's a Nigerian meal, right? So you can see it's going to return a query. That's the question basically. How do I prepare a Nigerian eba? So that's like the question. Then it's going to return the text, which is a response in this case. So it gives us the steps. So one thing to note um, is that the training data doesn't really factor much of Nigerian data, in my own view, in the sense that this process is it's not exactly accurate. So and sometimes you need to, if you're going to want to use any LLM for any project, you need to understand the context the training data was used on. So that way it helps the output or it helps your project. All right. So it's very critical. So yeah, I'm asking it, how do I start an aircraft? Obviously, I'm not going to start an aircraft, but I'm just asking it a question. As you can see, I have a query here, which is the question is returning here. Remember, we're able to define, we did this here, said the question and the question here in our bracket here. Okay, so coming down here, we have the question, how to start an aircraft. And here it gives us the method of starting an aircraft. Okay, cool. And this is in a dictionary. Cool. All right, so now let's move on. Now this is a different approach. It's a different templates. We're going to use a question answering or more like summarization, right? And what we can see here is so we are asking it for just a sec. I'm going to scroll up again. We're asking it for a question and like a new line on the question and answer. Okay. So now here, what do we have? We have the results. So so basically pretty much we already know that we have a Langchain method where we have a prompt and we pass the prompt we define here, the prompt variable that we define in this section here. So pretty much when querying this, via this particular template, what we're going to do right now is what I did here is I passed a new variable called result explanation. So okay, we can make this anything. Explain bacteria or explain. Let me use explain fungi. I think yeah, explain fungi in detail to me. Cool. So let's run this. So first of all, I'm going to run this because this is a different template. So I'm going to run this. Explain fungi to me. So it's going to explain fungi to you. So let's just wait for it. Okay. So all right. Okay. So sometimes it might take some time, but it's processing anyway, and it's going to give us a result, which is going to take step 3 for me. And I can check here as well to see what's happening with my processing and resource. I can see that I'm currently using 4.7 gig of 12.68 gig. So cool. I'm okay. I'm cool. All right. So now that has run. So we're now going to run this variable called result underscore explanation. I'm going to run this here. Yeah. So yeah. So this is the result, right? Fungi are a type of organism. So basically, this is pretty much what we asked our model. So more like a question answering system. So the next thing is I want to ask who is a service customer, who is a customer service manager rather, and explain it like a 5 years old. So this is pretty much the prompt. Now I realized that when prompting with things that have to do with codes and math, I mean the model was okay, was not bad, did very well, did cool, was okay for me. Like you can see in this prompt code I'm talking about, I have to pass two values that are a string, like 5 and 7, and then turn them into a list. A list basically is a type in Python. So I asked it to help with the procedures, and it wasn't bad in the way it was able to collate the answers together. So cool, not bad there. All right, so this is pretty much almost the same as we did before, but now this is quite different in the sense that I'm not using the prompt code here. I'm using this method we used before. Now the Langchain to how to convert how to convert is select. So let me just use select here. It's pretty much the same thing. Select how to convert is select everything in SQL table. Please explain to. So select is basically is a command that is used in SQL database, or in SQL, either Postgres, MySQL, or SQL Server, any one of it. So I asked the question, how to convert a select, yeah, everything. So I think pretty much let's use how to select everything in a no, let's move this here. How to select everything in okay, yeah, in the SQL table. Please explain this to. So let's run this and let's see. So we're gonna wait while it loads. All right, so it's still rolling, and we'll just wait. I'm going to check again to see what my resources are. So that's cool. Cool. So this method is cool for me. Cool. Yeah. So we're just going to wait a while. It's going to run, and then we're going to see what it looks like in terms of the results. All right, cool. So we have something, right? So it says that you can use the select command, so which is um, pretty much yes. So okay, you can use a white card. Yeah, this is basically how you do it in Postgres, or I mean, basically with SQL. So cool. That's fine. So the next thing is, again, we have a different kind of prompt. Now with large language models, basically you can write SQL queries even without you knowing SQL, without using SQL per se. All right. For example, if you take a look at this prompt in SQL, table columns, student columns. Now we're asking it. Okay, now we're asking it to just a second. Let's see. So we're going to prompt it with this particular information, like says, create a Postgres query for all students in the computer science department. So pretty much, ideally, I would have decided to use Postgres, but now I'm not making use of Postgres. I'm making use of my Langchain via my large language model. So as you can see, it was able to give me something very close, very cool in terms of the SQL prompt. So that's very interesting. So these are basically pretty much other methods or other examples, as the case might be. So finally, I think the Falcon 7B is cool, although it's not yet there. It has limitations depending on your nationality or the region you are based in the world. But I'm looking forward to exploring the Falcon 40B because I'm definitely sure that will be better and very cooler for other advanced projects. All right, thank you for watching this video, and I've dropped the source code and the Git repo. So do well to go through them and see my next video. Thank you.